Let's try this again. Hi, everybody. As you can tell, I'm not in class, and I've decided to make up a recording for you to go through our lesson today of 1.5 inverse functions. Please feel free to pause the video if you need to see what's happening. Speed up the video just in case I am going too slow. Do whatever you need to do so that you can effectively learn from today's lesson. I'm going to now share my screen with you to a Word document to tell you what our objectives are for today, and then we're going to switch to our handout. Just give me a second as I have difficulty with this. Let me share my screen with you. Hopefully this works. Hopefully you see on your screen is the outline that I want to cover. Basically, we're going to talk about inverse functions and what they are. We're also going to write down how we know how they actually are written. We're also going to look at them graphically and see what property that they have for them. And then finally, if we give you an equation, can you actually find its inverse equation? I'm actually going to block my face just to save some bandwidth. Speed it up really quickly. What is inverse function? Let me just move my keyboard out of the way so I can use my tablet more effectively. It basically is, if we have an ordered pair, and if we want to perform the inverse transformation, the definition is the coordinate swap. So xy now becomes y comma x. Let's do an example really quickly. Let's just say we have these 2 points. Sorry, this point, 2 and -3. To do the inverse operation, we're going to reverse the rule, and then the x coordinates and y coordinates swap. So 2 -3 now becomes -3, 2. The notation that we're going to learn eventually is finally looking f to the -1 to the x. That's how we write it. We're also going to notice what it looks like graphically, and I'm just going to spoil the fun right now. It's going to represent a reflection across y equals x. Finally, how to rewrite the equation and determine its inverse equation. The rule of thumb is swap y and x values, and then isolate for y. Please make note, not all inverses are functions. This will obviously make sense as we go through the package that we've given you from 1.5. I'm now going to switch screens. I'm going to stop sharing for a second, and then I'm going to share again our handout. Hopefully you can see this on your screen. So I'm going to read some things to you. Feel free to speed through things. You already know what a function is. It's a rule that associates the value of the independent variable x with one value of the dependent variable y to create a set of ordered pairs. So I'm actually right here to find out the inverse. What happens if we reverse the rule defining a function? So if a function is being squared, let's say x squared, the inverse is undoing that. So taking the inverse means to do the square root. For example, that's what I was trying to share with you. If we had this ordered pair of 3, 10 or 2, 1, to doing the inverse, and now that you know the symbol is this, notice the x and y values switch. The inverse function is the reverse of the original function. It undoes or undoes what the original function has done. It reverses the coordinates of the ordered pairs defined by the original function. Please make note, though, the notation for the function is f to the -1 bracket x. And again, the way that we read this is the f of inverse of x or the inverse of f at x. Please make also note, even though it looks like f to the -1, the inverse of a function is not the same as using the exponent to the -1. However, just to share with you, yes, what you're seeing in this example, 3 to the negative 1 is really the fraction 1 over 3. But when we talk about inverses, this is not true. So the inverse is not the reciprocal of a function. Let's take a look at some examples. Example 1. For each of the following, find the inverse of the function and state whether the inverse is a function. State the domain or range of both functions. I'm just going to do example A thoroughly, and then example B, I will just give you part of the answer. So let's do the inverse right away. One more time. That's how we write it. Inverse. Pause the video if you want to try to do it yourself. The function f at x is 0, 6, 1, 7, 2, 8, 3, 9. When we do the inverse, notice where we get 6, 0, 7, 1, 8, 2, 9, 3. Really easy. Notice we swap the x's and y's. For inverse. Now they're asking you to find the domain and range of both functions. So the domain for the original function a lot of you know x belongs to the integers such that x is equal to 0, 1, 2, and 3. The range of the original function, y belongs to elements of the integers such that y is equal to 6, 7, 8, and 9. I apologize, I'm going to be moving over to the left end of your screen. The inverse function, what is its domain? Well, its domain is x is an element of the integers such that what we have is x is equal to 6, 7, 8, and 9. What is the range? Y belongs to integers such that y is equal to 0, 1, 2, and 3. I'm going to highlight some things that some of you are probably obviously seeing. Notice the original function's domain is 0, 1, 2, 3. And notice the inverse, the range is 0, 1, 2, 3. Similarly, notice the range for the original function is 6, 7, 8, 9. Notice the domain of the inverse is 6, 7, 8, 9. So you can already tell there's some relationship between domain and range. For question B, I'll do this in blue if that's okay. And I apologize, it's off screen, really slow at the bottom of your screen. Let me just move this up a tad. We have g at x with the coordinates 3, 5, negative 2, 1, 4, 3, and 2, 5. To find the inverse, try it yourself, but I think you know you're going to get 5, 3, 1, negative 2, 3, 4, and 5, 2. Now let's take a look at our answers that we actually got. Notice, this is a function. Its inverse, for every element of x, there's only one output. However, for question B, and I apologize, this is smaller in pink, we have 5, 3, 1, negative 2, 3, 4, and 5, 2. This is a relation. Hopefully that made sense. Feel free to refer to the textbook. We're now going to take a look at example 2. Example 2, I'm going to slightly do differently. Pause the video if you want to try it yourself. This is the part where we're going to look graphically the properties of any kind of given information. For the example that we're going to be looking at, we have f of x is equal to negative 2, 0, negative 1, 1, 0, 3, 2, 6. Take a moment to plot it yourself. Try it yourself. I'll try to do this quickly. That's negative 2, 0, that point there. Negative 1, 1 is right there. 0, 3 is right there. 2, 6 is over here. Now, what's interesting, although question B says to find the midpoints, I'm going to do this a little differently. By connecting the dots, you might see an image. Not the best image, but that's okay. I'm going to use a different color to find the inverse. And again, try it yourself. Pause the video. But what you should be getting out of this is that we are going to swap the x's and y's, and we get the following data points. So we have now the transformation of 0, -2, 1, -1, 3, 0, and 6, 2. Maybe I should fix my bracket there. Much better. Where is 0, -2? 0, -2 is right there. Where's 1, -1? Is right there, that dot that I placed there. 3, 0, it's right there. And 6, 2 is right here. Notice we're going to connect exactly in the same order. And it doesn't seem obvious, but I think some of you might remember from the earlier video. I'm going to draw y equals x. All inverses are reflected across this line. Where is y equals x? It happens to be this line that I'm drawing carefully. So really what this question is actually exploring, find the chords of the midpoints of the line segments if you were to connect them by joining the corresponding points. So this point and this point, notice they meet right here. Notice this point and this point, whatever that value is, meets right there. Notice this point and this point, meet right there. Notice this point and this point, meet right there. Also, I'll try to make sure we have these colors. The original function is g at x. Sorry, my apologies. F at x. And the inverse is this one. Note it's not being upside down. It seems like it's rotated on an angle of 45 degrees to the right. So all inverses are reflected across this y equals x line. That's a property of all inverses. Now let's take a look at example 3. And again, let's just scroll back to the instructions. So to find the equation of the inverse is this orange part that I squared for you. Pause the video if you need to read it yourself. And it's relatively easy. Let's take a look at the examples that we're going to look at from example 3. I'm just going to move it up. The first thing that you're supposed to do is rewrite the equation. So we have f at x equals 3x plus 2. And this is a straight line. So notice in grade 9 and grade 10, we just change f at x to y. Watch what I'm going to do. The next thing is swap the x's and y's. And seriously, students, x equals 3y plus 2 is a valid equation. Nowadays, GeoGebra, Graphmatica, and Desmos, they actually understand how to graph this. But this is considered bad form because we always isolate for y. So to speed this up, what I'm going to do is subtract 2 to both sides because in order to isolate for y, we use reverse BEDMAS. So what we get is x minus 2 is equal to 3y. And then divide both sides by 3. What we get is y is equal to 1/3 x minus 2/3. So this is the inverse equation. However, the proper way of writing this, because it is a function, we write it like this. So one more time, the way that we say this, inverse is 1/3 x minus 2/3. And yes, this is a function. For the next one, notice, same idea. Pause the video if you want to try it, do it yourself. We have y equals 2 times x minus 3 squared plus 4. This is clearly a vertex form of a quadratic. Swap the x's and y's. and now do reverse BEDMAS. This time I'm going to actually show my steps, just in case I went too fast with reverse BEDMAS. So we deal with that 2 times y minus 3 squared plus 4. The first thing we're going to deal with any adding, subtracting. The negative 3 is in brackets, so we can't do that. So I'm going to move this 4 over to the other side by subtracting. That's what we get. X minus 4 is equal to 2 times y minus 3 squared. What are we going to do next? We deal with that multiplication of 2. How do we do that? Opposite of multiplication is division. And what we're left with on the right-hand side, we get y minus 3 all squared. And on the left-hand side, we get half x minus 2. Here's the key part. From grade 10, a lot of you remember the opposite of squaring, and that's why we reviewed it earlier in the video. The opposite of squaring is square rooting. So we square root both sides. And the key thing for this, when you square root an equation, yes, on the right-hand side, we get y minus 3. But on the left-hand side, what we get is plus or minus the square root of half x minus 2. Finally, to move that negative 3 back over to the other side, the opposite of subtracting by 3 is adding by 3 to both sides. Now I'm going to make this look a little neater, because again, we write y is equal to plus or minus the square root of half x minus 2 plus 3. Now technically this is the correct equation. I'm just going to move this up. But because this is not a function, and we'll try to explore that in class, and if you actually wanted to type this in to Desmos or Graphmatica or GeoGebra, you'd realize this is not a function because it fails a vertical line test. So although we want to express its inverse, we write it as y to the negative 1. This is not a function. Finally, example 4, the last question of the lesson. Let's just read it quickly. Given the function, graph its inverse. I'm going to zoom in so people can see a bit better. And to help you with this last question, I'm going to hopefully make you focus on this function of g at x. And I'm going to take 2 key points. First key point is probably 0, 3. I'm just going to point to it so that people can see it. And the other key point is down here, and that's 5, 0. So we want to do the inverse. I'll use red. What does inverse mean? We swap the x's and y's. And now let's plot this. Graph its inverse. Notice you can take any other nice point. I could have taken negative 8, 8, and maybe 8 and negative 2. But I decided to take the key points on the x-axis and the y-axis. So let's plot these now. Where is 3, 0? 3, 0 happens to be right here. 0, 5 happens to be right there. And let's just draw this line. It's pretty good. And this is the inverse. To reiterate one more time, all inverses are reflected across this green line that I'm drawing. One more time, that's what inverse means. A reflection across the y equals x. That's why when you tilt your head, you can see a really neat pattern. So there you have it, students. We've actually covered 1.5 inverse functions. One more time, orally. Inverse means to swap the x's and y's. They're reflected across the y equals x line. And now you know how to isolate for the equation by swapping the x and y's and isolating for the y value by doing the reverse BEDMAS. Hope you found this video informative, and I'll catch you later. Thanks for watching.